The second reaction that alkenes undergo is addition reaction. So an addition reaction is a reaction in which a molecule is added to a compound containing a double or a triple bond to form a single product. So in an addition reaction, what will happen here is that this double bond is going to be broken down, so you'll end up with a single bond here, and this molecule is going to end up being added here in this molecule, so that you end up with a single product like that. So you start with two substances, 1, 2. This is the unsaturated alkene, unsaturated because it has a double bond. You could also have an alkyne with a triple bond undergoing addition reaction. So anything that is unsaturated, like an alkene or an alkyne, can undergo addition reaction. So addition reaction, you end up with one single product where you have the molecule that will add across the unsaturated part. So here we're talking about the double bond as the unsaturated part, which will be broken to form a single bond, and atoms are added in the position where the C double bond C was present. So there's 5 addition reactions undergone by alkenes that you will study: addition of bromine, addition of chlorine, addition of hydrogen, addition of steam, and addition of hydrogen halides. Addition of bromine, you're going to have bromine that just adds in between the double bond. The reagent is bromine dissolved in any inert solvent, so bromine dissolved in CCl4, and it's going to occur at room temperature. So here you have ethane plus bromine, so you will end up with dibromoethene, like this. But you can show the equation. So you have the bromine here that is going to be added in between the double bonds. So you will have C, Br, Br, and then see the bromine adds in between the double bond. For this one, you can show it like this, or you can show it as CH2Br, CH2Br. You can also show it like that. That's fine. Another example, so C3H6, let's say it's like this. And you're going to add the bromine. So the bromine is going to add in between the double bond here. So you can just, so CH3, CH, Br, CH2, Br. Or you can just simply write it as C3H6Br2. The third example, so here you have the bromine that's going to add in between the double bonds, so you will end up with, let's see the naming of these compounds. So this one is ethene, so you add the bromine, so it becomes 1,2-dibromoethane. Okay, there's no double bond anymore, so it's ethane. Here you have 1, 2, 3, so propene or prop1ene or 1-propene, and here you end up with 1,2-dibromo-propane. This one here, it is cyclohexene, and you end up with 1,2-dibromocyclohexane. So you should be able to name whatever products you're getting. You're familiar with naming from unit 10.1. Now, observations during this is that whenever you have bromine added to an alkene, if you have an unsaturated molecule, you're going to see the decolorization from reddish brown to colorless. Oily droplets are also produced. So there's two observations for these reactions. So you have the decolorization, like you can see. So you have the alkene, which is bubbled here. So you see the tube here, it's bubble inside the bromine water. And you have oily deposits, oily droplets also formed. And this is a test used to distinguish between saturated and unsaturated compound, between an alkane and an alkene, or between an alkane and an alkyne. The unsaturated compounds will decolorize bromine, and with the saturated compound, so the alkane or anything that has no double bond, there is no decolorization. When I'm saying unsaturated compound, it could be double bond or it could be triple bond. Now, instead of using, here we said that we're going to use bromine dissolved in CCl4. Instead of using CCl4, we can also use bromine water. That's aqueous bromine, that is bromine dissolved in water. This can also be used, and you will see the same observation. The next reaction is addition with chlorine, and addition in chlorine is the same thing. So you're going to have chlorine added in the double bond. And here the observation is that the color changes from yellowish green to colorless. So chlorine is yellowish green, and when it reacts, the color is going to go away, so from yellowish green to colorless. And then the characteristic smell of chlorine has the smell of bleach, and this smell is going to disappear. These are the two observations. The next addition reaction is addition of hydrogen, which is also known as hydrogenation. So you're adding hydrogen in this, and when alkenes react with hydrogen, they produce the corresponding alkane. So here you have the equation with the general formula. And the reagent here is hydrogen gas, temperature 150 degrees Celsius with nickel catalyst. You need to know the conditions. So for example, here you have propene. This is going to form propane. Butane with hydrogen. So butane with hydrogen, you end up with butane. And you can see here where you have the hydrogen which has been added here. But-1,3-diene. Diene means there is two double bonds. 1,3 is the position of these double bonds. So here you have to be familiar with the naming so that you can draw the molecules and that you can write the products. So 1, 2, 3, 4, because it's but, and then 1, so 1, 2, 3, 1, 3, so that's the diene, and you fill up with hydrogen, and when you add hydrogen you will end up with butane. You can draw the butane molecule over here. So take the habit to write the conditions and the catalyst on the arrows. You're going to be practicing the conditions so that you know them. Cyclohexene is this here, and you add hydrogen, you end up with cyclohexane. The hydrogenation reaction is a very important reaction. It's used to convert alkenes to alkanes, and this is going to be used for fuel in car because alkanes are more important fuels than alkenes. And also hydrogenation is used to convert vegetable oils to margarine. Vegetable oils are fully unsaturated, which means that they contain several C double bond C. When you add hydrogen to it, you break these C double bond C, you turn them into single bonds, and when you have more single bond, it makes the melting point increase so that the vegetable oil changes into a solid that can be spread. So margarine is just vegetable oils, but vegetables, you're not going to spread vegetable oils on your bread, so you're going to spread margarine. So they break these double bonds, turn them into single bonds so that the melting point increases and that it changes into a solid that can be spread. The next addition is addition of water. When you add water to alkenes, you end up with alcohol. So you're just breaking the double bond and you're adding H and OH, because that's water, H and OH. Okay, so this breaks and this adds into the double bond. So because you have an OH here, so you end up with an alcohol. So the conditions is steam, catalyst is concentrated sulfuric acid, and concentrated sulfuric acid produces H plus and HSO4 minus intermediates. These ions will add in the double bond first, and hence will make it easy for the OH to fit in. So the HSO4 will fit on one side, so the HSO4 will fit here, the H plus will fit here, and then eventually the HSO4 is going to move away and leave space for the OH. Okay, so this is normally what happens. You don't need to know any mechanism for now. So the large-scale production of ethanol is achieved by reacting ethene with phosphoric acid at 300 degrees Celsius. And this is an important reaction for the formation of ethanol, which is a solvent. And ethanol is also used in the formation of biofuel. So it's added to petrol to turn it into a biofuel. The last addition reaction is addition with hydrogen halide. So where you're adding any hydrogen halide, so HBr, HCl, HI, these are going to be added across the double bond. So for example, here you have ethene, so across ethene you're going to add HBr, so H is going to add